Hello students, last time we saw examples based on the standard results. Okay, that was the standard results part 2. Okay, now we'll see integrals of this type. Okay, so either it is given some polynomial into ax plus b raised to n, that is a linear polynomial raised to n, or px, there is a root, okay, nth root over the linear polynomial. So we'll see one example. Integral x minus 5 upon dx. Okay. So first you have to put here the method of substitution works. So 2x minus 1 to put as t. Okay. So after the differentiation, it is going to become 2 dx equal to dt, right? Okay. Now we have to substitute for this term, that is here you have to put now from here we can find out x, right? So 2x is what? T plus 1. Okay, so x is t plus 1 by 2. Okay, so you can put here in place of x t plus 1 by 2. So let's substitute. So this becomes integral t plus 1 by 2 minus 5 upon, this is root, so this is 4 is given, so it is 4th root, so we can write it as t raised to 1 by 4. Okay, and dt is our 2 dx, so dx becomes dt by 2, dt divided by 2. Okay, just rub this, later on we can use that. Okay, I will keep this. Now solve. So this, if you cross multiply, you will get t plus 1 minus 10 upon 2. Okay, this 2 I will take outside, and this is t raised to 1 by 4, so I will keep here only t raised to 1 by 4 dt. Okay, so again you can take out 2, so this will be 1 by 4, so this becomes this is minus 9, so t into t raised to 1, t raised to minus 1 by 4. Okay, because we are taking it in the numerator, minus 9 into t raised to minus 1 by 4. Okay, now it's easy. So use laws of exponents. T raised to 1 into t raised to minus 1 by 4 is t raised to 1 minus 1 by 4, right? So this will be t raised to minus 1 plus 1 by 4. Cross multiplication will give you minus 4 plus 1, which is minus 3 by 4. So t raised to minus 3 by 4 minus 9 plus 1 by 4 dt. Now you have to integrate. So after integrating, you will get 1 by 4 is outside. So t raised to minus 3 by 4 plus 1 upon minus 3 by 4 plus 1 minus 9 t raised to minus 1 by 4 plus 1 upon minus 1 by 4 plus 1 plus c. Okay, so this becomes, I'll drop this, one by 4 is outside. So t raised to minus 3 plus 4, so 1 by 4 upon 1 by 4 minus 9 t raised to minus 1 plus 4, so 3 by 4 upon 3 by 4 plus c. Okay, So this is 4t raised to 1 by 4 minus 4 by 3 into 9 t raised to 3 by 4 plus c. So this will be 12. And then you have to substitute whatever t you have taken. That is t is 2x minus 1 raised to 1 by 4 minus 12 2x minus 1 raised to 3 by 4 plus c. Okay, this is your final answer. Let's solve this. So in this, it is of this step, that is some polynomial into the nth term. Okay, so again you have to do the same thing. So x minus 5 you have to put equal to t. Okay, so dx is dt. Okay, so from this you can write what is x is your t plus 5, right? So substitute. So substituting here, we'll get integral 2 times x is t plus 5 minus 1, and this is t raised to cube. Okay, and dx is dt. Okay, now it's easy. So this will be 2t plus 10 minus 1 into t cube dt. So 2t into t cube is t raised to 4. Okay, t raised to 1 into t raised to 3. So 3 plus 1, 4. Plus 10 minus 1 is 9. So 9t cube dt. So integral of this is t raised to 5 upon 5 plus 9 t raised to 4 upon 4 plus c. Now I have to substitute for t, which is x minus 5. So t x minus 5 raised to 5 upon 5 plus 9 is 5 raised to 4 upon 4 plus c. This is your final answer. So this is one more of a kind. Okay, so here integral dx upon a sin x plus b cos x plus c is given. Okay, so here you have to substitute in place of sin x, that is you have to put 10x by 2 as t. Okay, so x by 2 will be what? 10 inverse of t, right? So when you take the derivative, this will be dx by 2, and 10 inverse of t is 1 upon 1 plus t square, right? dt. So this substitution you have to make. So in place of x, you have to put 10 inverse of t to 10 inverse of t. Okay, so I will just write this here. So x you have to put 10 inverse or this sin x you have to convert into 10. Okay, in terms of 10 you have to write. So using those identities which you have learned in your 11th standard, that is sin x, using the half angle formula, it becomes 210 x by 2 upon 1 plus 10 square x by 2, and for cos x it is 1 minus 10 square x by 2 upon 1 plus 10 square x by 2. Okay, so this is okay, I will write here sin x using half angle formula, 210 x by 2 upon 1 plus 10 square x by 2. So in place of 10x by 2 you have to write t. Okay, t square, and cos x is nothing but 1 minus 10 square x by 2 upon 1 plus 10 square x by 2. So So 1 minus t square upon 1 plus t square. Now we'll see one example. Okay. Integral dx upon 3 sin x plus 4 cos x plus 1. Okay. So in place of sine and cos, you have to put this. Okay. So let's substitute. In place of dx, you have to write dt, which we have derived, that is 2 dt 1 plus t square. Okay. That is the derivative of 10x by 2. 10 was t. Okay. So 3 sin x is 2t upon 1 plus t square. Cos x is 1 minus t square upon 1 plus t square. Okay, plus 1. So here the denominator is 1 plus t square, 1 plus t square, common denominator. So I have to multiply here and divide here by 1 plus t square, because here 1 is there, right? Now all three denominators are same, so I can add that term. Okay, and here also the denominator is 1 plus t square. So this denominator and this denominator gets cancelled. So we will get 2 dt upon, adding these terms, 3 into 2, 60, 4 minus 4t square plus 1 plus t square. Okay, so this will be 2 dt upon 60, then 4 plus 1 5 minus 4t square plus t square, so minus 3t square dt. Okay, now this is your quadratic equation, right? So you have to solve it, quadratic equation. So we have seen how to solve integrals which have denominator a quadratic equation. So first this 3 should go, so I will divide by 3 and multiply by 3. Okay, so this 2 by 3 will come outside. So integral is there. Okay, dt upon this will be 5 by 3. I will write first, then that is 2 by 3 t and minus t square, right? Not 2 by 3, this is 2t. Now we'll take here minus sign outside, so this will be t square minus 2t, right? Okay, now this is t square minus 2t, that is t square minus 2 into 1 into t. So our 1 becomes the b, so a minus b the whole square. So plus 1, and this minus sign is there, that's why I'm adding here 1. Okay, so this will be integral dt 5 by 3 plus 1, which is 8 by 3. This will be t minus 1 the whole square. Okay, so this is root square. Okay, so this is a square minus x square. So a square minus x square is 1 upon 2a. 1 upon 2a. A is root 8 by 3 log a minus x is there, no? So a plus x you have to take. So this will be root 8 by 3 plus t minus 1 the whole square upon root 8 by 3 minus t minus 1 the whole square plus c. Okay, this is the final answer. Last you have to substitute for t. Whatever t we have taken, you have to write it here. Okay, then that becomes your final answer. Okay, so third type is where the integral contains this type of terms. Okay, that is the some x raised to 1 by 4, or that is fractional powers are there. Okay, so in this type you have to put x equal to t raised to n. Okay, and then you have to see the powers of both. Okay, of whatever integrals are given, okay, fractional powers, and then you have to take the LCM of that. Okay, and then you have to multiply it. So we'll do one example. Okay, dx upon x raised to half plus x raised to 1 by 3. Okay, now LCM of 2 and 3 is 6, right? So when you take x raised to t raised to n, that time n should be the LCM. Okay, so t raised to 6. So our derivative of this will be 6 t raised to 5. Okay, now you have to write this. X raised to half means t raised to, convert them, half is t raised to 6 raised to half, right? So this will be t raised to cube, and x raised to 1 by 3 is t raised to 6 raised to 1 by 3, which is t square. Now you have to substitute it in the integral. In place of dx, it will be 6 t raised to 5 dt, and x raised to half is our t cube, and x raised to 1 by 3 is t square. So from the denominator you can take t square common, right? So this will be t plus 1. So this and this goes, and you will get 6 raised to 5 minus 2 it is. So this is 3, right? T plus 1 dt. Okay. Now this is your denominator. So denominator term, you have to make it equal to, we don't want a denominator like this, right? So we'll do one thing, that is we'll add and subtract 1 in the numerator. Okay, 6 will take outside. I will write here only. So plus 1 and minus 1 dt. Okay, so separating out the terms, I will get 6 t cube plus 1 upon t plus 1 minus 1 upon t plus 1 dt. Okay, so 1 upon t plus 1. So this term is you can directly integrate, that is log of t plus 1, right? So for this term you have to do the long division or the division algorithm. So after that you will get the term quotient, which is t square minus t plus 1. Okay, after doing the division algorithm, I will not do that. It's easy, you can do it on your own. T plus 1 is the divisor and t cube plus 1 is your dividend. Okay, so you get the quotient t square minus t plus 1 minus, this is dt, okay, minus log of t plus 1. This is the integral of this term. Okay, so I will write here. Now you can integrate this. This is easy. 6 t square is t cube by 3 minus t square by 2 plus t, okay, minus log t plus 1 plus c. Okay, so in place of t you have to put x. Now we had taken x equal to t raised to 6, so t will be x raised to 1 by 6. Okay, so in place of t you have to put x raised to 1 by 6. Okay, then that will be your final answer. Okay.